GeopByte.
Welcome to GeopByte. Hi students. Today let us know about Class 7, Chapter 1, Integers. As you know, integers form a bigger collection of whole numbers and negative numbers. Let us see. Whole numbers. Whole number starts with 0, 1, 2, 3 and so on. Always whole number starts with number 0. If 0 is not there, only if we will start with 1, 2, 3 and so on, they become positive numbers. If 0 is there, they become whole numbers. Let us write negative numbers. Negative numbers are indicated with minus symbol. Minus 1, minus 2, minus 3 and so on. Now let us construct a number line. As you know, a number line consists of whole numbers and negative numbers. Let us do it. This is a number line. Now let us represent numbers on it. Always the center number must be 0. Remember, always the center number must be 0. Now there should be positive numbers on right side and negative numbers on left side. Let us write. Positive numbers on this side. Negative numbers on this side. As I said, if 0 is there, these numbers become whole numbers. If 0 is not there, only from 1 to 3, it will become positive numbers. That's why I have written positive numbers. Let us write the numbers now. 1, 2, 3, 4, 5, 6, 7. Let us write the negative numbers here. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. We can represent a number line like this. We can write any number up to infinity on this side and this side. Now let us see ascending order of these numbers. As you know, ascending order means writing from the smallest number to the biggest number. Let us see in these numbers. Here we will consider the smallest number as negative numbers. Not only here, anywhere, if positive numbers and negative numbers are there, always the smallest number is negative number. Let us write. Ascending order. Ascending order. Now let us take the number minus 3. Next what we have? Let us see towards 0. Minus 3, minus 2, minus 1, comma, 0, 1, 2, 3, 4 and so on. 0, 1, 2, 3 and so on. This is the ascending order. As I said, always smallest number will be the negative numbers and the biggest numbers will be the positive numbers. In between there will be a 0. If we take in the case of number line. Now let us write descending order. Descending order means writing from the biggest number to the smallest number. Biggest number means the positive numbers are biggest numbers and the negative numbers are smallest numbers. Let us write this sequence in reverse. 3, 2, 1, 0, minus 1, minus 2, minus 3. Now let us see some examples of integers. If I take minus 234, yes, it is an integer because we have negative numbers in integer. If I take minus 25643, yes, this is also an integer. We should not consider the length of the number. We should consider the negative symbol and the numbers. Now, let us see different cases. If we take root 6, is this an integer? No, because under roots cannot become integers. And fraction 1 by 2. This also will not become an integer. And let us take 2.3. Decimals. Decimals also will not become integers. As you know, positive numbers also are integers. Positive numbers, negative numbers and whole numbers only can become integers. Under roots, fractions, decimals cannot become integers. Now let us know about addition and subtraction. In this topic, we will learn 4 basic rules. Many will do mistakes in considering these basic rules. Now, we will learn them clearly. First, let us consider a plus symbol and a plus symbol. What will be the result? Plus plus becomes plus. That is, we need to add. Now, let us consider a plus and a minus. If there is a plus and a minus, we need to subtract. If there is a minus and a plus, we need to subtract. If there is a minus and a minus, we need to add. Now I will show you these basic rules with some examples. Now, considering this rule, I have 2 positive symbols, that is 2 plus symbols. Let me take 5, 2. If there is nothing to this number 5, there is considered to be plus. So, 5 plus 2 is 7. First rule is completed. Now, let us see the second rule. If we have 5 minus 2, let us take the same 2 numbers for all the rules for better understanding. Now, if we have 5 minus 2, don't think that here is nothing. 5 is there means here plus is there. The 5 is plus 5 and the 2 is minus 2. Now, what is the rule I said? If plus minus are there, we need to subtract. Plus, minus, we need to subtract. 5 minus 2 is 3. But the symbol will be positive because the bigger number has the symbol positive. Remember this. If we do subtraction, see the symbol for bigger number. What is the symbol for bigger number? Plus. We need to write plus. So, the answer came in positive, that is plus 3. Now, let us see this rule. We have minus plus. Let me take minus 5 plus 2. In this condition, same. We have minus and plus. We need to subtract. Similar to this. But if we subtract 5 minus 2, we get 3. And I said, check the symbol. I have minus for bigger number. We need to write minus 3. Again, here we wrote plus 3. If nothing is there, it is assumed to be plus. Right? Here we got plus 3 and here we will get minus 3 because the symbol for the highest number is minus and symbol for highest number is plus. Remember this. Very important. Now, let us see the last rule. We have 2 minus. Minus 5 minus 2. We need to add when 2 minus symbols are there. I have written here. We need to add. Now, minus 5 minus 2. Let us add. 5 plus 2 is 7. Let us write 7. In this condition, whatever may be the number, maybe the highest number, maybe the lowest number. The thing is, we need to represent with minus symbol. Because the both numbers have minus symbol. But the rule is, we need to add and the symbol must be negative. So, these are the 4 basic rules which are to be remembered. And these are 5-star information. Many people will do many mistakes, even though if we solve big problems, in that the minor mistake of these symbols leads to a major issue. That's why remember this information carefully. Now, let us know about the properties of addition and subtraction of integers. Yes, in these properties, we have 2 properties. Let us go with the first one, commutative property. In this property, we have A plus B is equal to B plus A. A plus B is equal to B plus A. That is, whatever the numbers we have on the left hand side should be satisfied. That is, should be equal to the right hand side. Let us see with examples later. Now, let us see the associative property. Yes, in this property, we have A plus B plus C is equal to A plus B plus C. Now, see here, we have A plus B plus C is equal to A plus B plus C. Here also, the numbers which are on the left hand side should be satisfied. That means should be equal to the numbers on the right hand side. Now let us see with some examples. First, let us take A is equal to some 4 and B is equal to some 6. Now, let us check these two properties with these two numbers. We have the first property as A plus B is equal to B plus A. So, let us write here A plus B is equal to B plus A. What we have the number A? We have 4 plus we have B as 6. 4 plus 6 is equal to 6 plus 4. What is 4 plus 6? 10 is equal to 6 plus 4, 10. Yes, it's proved. This property is proved that LHS is equal to RHS. Now, let us see the second property. We have A plus B plus C is equal to A plus B plus C. We have A as 4, B as 6. We don't have C. Let us take C is equal to some 2. Now, let us substitute these numbers in these alphabets. A is 4 plus B is 6 plus C is 2. That is equal to A is 4 plus B is 6 plus C is 2. Now, let us add 6 plus 2 is 8 plus we have 4 is equal to 6 plus 4 is 10 plus 2. What is 8 plus 4? 12. 10 plus 2? 12. Hence, we proved that LHS is equal to RHS. What may be the condition? That is, wherever may be the brackets, but the signs are positive, then we'll get the answer LHS is equal to RHS. Till now, we have seen the examples of properties of addition. Now, let us see the examples regarding the properties of subtraction. Let us see. Let us consider A some 2, B as -1, C as 3. Now, I have involved the number which is negative. Let us prove these two properties. First, we have commutative property, that is A plus B is equal to B plus A. Let us write A plus B is equal to B plus A. Yes, now we have A as 2 plus B we have -1. Let us put it in a bracket because two symbols cannot be side by side. So, we need to put a bracket is equal to, we have B as -1 plus A 2. Now, let us solve. We have 2. As I said the rules before, plus and minus are there means we need to write minus. -1 plus into minus is equal to -1 plus 2. This is the thing we have here. Now, what is 2 minus 1? 1 is equal to, we have a minus and a plus. The condition is we need to subtract. If a minus and plus is there, we need to subtract. 2 minus 1 is 1. One more condition also I said, that we have to check the symbol for the greater number. We have plus for greater number. So it is plus 1. We proved that LHS is equal to RHS, that is 1 is equal to 1. Right? Now let us prove associative property. Let us take this. A plus B plus C is equal to A plus B plus C. Yes, this is the property, right? Now we will substitute these numbers in this property. We have A as 2 plus B as minus 1. See, we have bracket here. Again, we have to put this minus 1 in a bracket. Plus C is 3 is equal to A is 2 plus B is minus 1. Plus is there. Again, we need to put a bracket. Write minus 1. Close the bracket. Plus C is 3. Now, let us write 2 plus, we have minus 1 plus 3 inside is equal to, here we have 2 plus into minus, minus 1 plus 3. We have solved this step. Now, let us furtherly solve. 2 plus, as I said, if a minus and a plus is there, we need to subtract. 3 minus 1 is 2. As I said, the symbol for the greater number should be considered. So, 3 has plus and 1 has minus. So, we got the answer 2. The symbol will be plus and is equal to 2 minus 1 is 1 plus what is left? 3. What is 2 plus 2? 4 is equal to 1 plus 3 is 4. We proved. So, we proved the properties of addition and subtraction of integers with some examples. Now, let us see the next topic, properties of multiplication of integers. In this topic, we have two properties. That is, the first one, commutative property. In this property, we have A into B is equal to B into A. Similar to the additive and subtractive properties, in multiplication properties also, we have same. There we have plus, now we have into. Same property, only the symbols has changed. A into B is equal to B into A. Now, let us see associative property. In this property, we have A into B into C is equal to A into B into C. Yes, this property is also similar to that. But what has replaced is the plus became into. Now, let us see these two properties with some examples. Let us consider A is equal to 4, B is equal to 6. Now let us substitute these two in this commutative property. A into B is equal to B into A. This is what the property we have. Now let us substitute these two numbers and verify. We have A is equal to 4 into we have B as 6 is equal to we have B as 6 into A as 4. As you know, 6 fours are 24. 6 fours are 24. Yes, it's proved. Similarly, let us do with associative property. A into B into C is equal to A into B into C. We have A here, B here, and we don't have C. Let us take C as some 2. Now let us write A is 4, B is 6, C is 2 is equal to we have A as 4, B as 6 into C as 2. Now let us multiply. 4 into, now let us multiply the numbers in the bracket. 6 2s are 12 is equal to 4 6 are 24 into 2. We have different numbers on either sides, but 4 12s are 48. 24 2s are 48. Proved. Since we have proved with examples these two properties. Now let us discuss about the zero concept. Zero concept. Now let us see the role of zero in additive properties, subtractive properties, multiplicative properties. Now see, coming to the additive properties, let us take in the form of 5 plus 0. What is the answer? It is nothing but 5. That is 0 place nothing. Only whatever left instead of 0 to be written in the answer. Now similarly let us see about the subtractive property. In this condition, if we take minus 5 plus 0. So in this condition also we will write only minus 5. Means we will write the thing instead of 0. Whatever is left, that we will write. Now if we take in reverse, 0 minus 5 is equal to. Same, the symbol for 5 is minus. 0 is negligible. We will write minus 5 itself. Now let us see in the multiplication condition. 0 into 5. Anything that is multiplied to 0 is 0. That's all. Anything you take to any number into 0 is finally a 0. Now let us see in the case of division. If any number some 100 by 0 is infinity, that is no solution. If 0 by any number is 0, this is the condition in division. See, any number by 0 is infinity and 0 by any number is 0. Infinity, or this is also called no solution. Remember this. This is very important. Any number by 0 is infinity and 0 by 100 or 0 by any number is 0. This is the concept of 0 in the case of addition, subtraction, multiplication and division. Now, let us solve some problems from exercise 1.1. This is the first problem. Following number line shows the temperature in the degree Celsius at different places on a particular day. There is a number line given and temperatures also in degree Celsius. Now, let us see bit A. Observe this number line and write the temperature of the places marked on it. It is given that there are some places given on this number line. We have to identify the related temperature of that place. Let us write one by one. The first one is Lahulspiti. At Lahulspiti, we have, as I said, in a number line, we have positive numbers on the right side to the 0 and negative numbers to the left side of the 0. So here we have negative numbers. After 0, -1, -2, -3, -4, we already have -5, -6, -7, -8, -9, -10. As so, now here what we got? -8. I'll write and show. -1, -2, -3, -4. Already -5 is given. -6, -7, -8, -9. Now at this point I have -8 degrees Celsius. Let us write -8 degrees Celsius at Lahulspiti. Now we have Srinagar. At Srinagar we have -2 degrees Celsius. Let us write. At Shimla, now coming to the positive side, after 0, 1, 2, 3, 4, 5 is given, 6, 7, 8, 9, 10 is given, 11, 12, 13, 14, 15 is given, 16, 17, 18, 19, 20 is given, 21, 22, 23, 24, 25 is given. Now, at Shimla, what is the temperature we have? 5 degrees Celsius. Let us write. Now, at Ooty, we have 14 degrees Celsius. Next, at Bengaluru. At Bengaluru, we have 22 degrees Celsius. These are the different temperatures at different places on the number line. Now, let us see bit B. What is the temperature difference between the hottest and coldest places among the above? In this number line, the numbers or temperatures which are towards the right side of 0 are positive numbers and are highest or greater numbers compared to the negative numbers which are lowest numbers. Now, in these numbers, we have Bengaluru at the hottest temperature, that is highest number 22 degrees Celsius. Bengaluru has the hottest temperature 22 degrees Celsius. Now we have the coldest temperature as. Coldest means, now coming to left side of the 0 which are negative numbers. In these numbers, the extreme coldest place, that is Lahulspiti, it is at -8 degrees Celsius. Lahulspiti is at -8 degrees Celsius, coldest temperature. Now, what did they ask? What is the temperature difference? Difference means subtraction. Let us write 22 minus, we have -8. I said when there are two symbols side by side, we need to put a bracket. Now, when two minus symbols are there, minus into minus becomes plus. I have already said in multiplication condition, minus into minus becomes plus. Similarly, minus into minus becomes plus, and we have the number 8. 22 plus 8 is 30. 30 degrees Celsius. We have the temperature difference between hottest and coldest place is 30 degrees Celsius. Now, let us see bit C. What is the temperature difference between Lahulspiti and Srinagar? What is the temperature at Lahulspiti? -8 degrees Celsius. At Srinagar, -2 degrees Celsius. They asked to find out temperature difference. Difference means we need to subtract. -8 minus -2. We need to put a bracket because two symbols are side by side. Now, write 8 as it is. Minus into minus plus 2. Now, we need to subtract because there is one minus, one plus. 8 minus 2 is 6. Another condition you need to remember is we have minus to the larger number. That is, we need to put minus to the answer. So, the temperature difference between Lahulspiti and Srinagar is -6 degrees Celsius. Now, let us see bit D. Can we say temperature of Srinagar and Shimla taken together is less than the temperature at Shimla? Is it also less than the temperature at Srinagar? Let us see. Let us write the temperature at Srinagar. We have -2 degrees Celsius. And at Shimla, we have 5 degrees Celsius. They asked temperature of Srinagar and Shimla taken together means we need to add. Taken together means we need to add. -2 plus 5. -2 plus 5. We have a minus and a plus. If there is a minus and a plus, we need to subtract. 5 minus 2 is 3. And the symbol is the symbol which we have for the greater number. We have plus to the number 5. So it is plus only. We got 3 degrees Celsius. Now what is the question? Can we say temperature of Srinagar and Shimla taken together is less than the temperature at Shimla? What we have Shimla's temperature? 5 5 degrees Celsius. What we got? 3 degrees Celsius. Yes, we got temperature less than Shimla's temperature. Now let us see the next one. Is it also less than the temperature at Srinagar? Srinagar's temperature is minus 2 degrees Celsius. We got 3 degrees Celsius. No, it is not less than the Srinagar's temperature. It is more than the Srinagar's temperature. That is 3 degrees Celsius is more than the Srinagar's temperature.
GeopByte.